Right, and we're back with some more functions, and let's start dilly-dally about. Let us make it maths. It's too good, go on. Okay. So, today we're doing inverse functions. For inverse functions, our two key takeaways are, I always forget where everything is. Up here. Okay, so our two key takeaways are this. Everything that was x is now y. Everything that was y is now x. That's the one key takeaway. And the other key takeaway is that we're reflective around about the line y equals x. Okay, so we're like, what is going on? That's the point of the four examples today. So let's have a look here. We've got example number 1. What a great place to start. F of x equals y equals 2x minus 6. So pop that down, and when you pop it down, think what type of function is it and can you sketch it? And with that little jump, we have got a straight line, right? So we've got a straight line going along here, and so let's sketch our straight line. And so instead of axes is useful, x, y, here we go, and we've got this line. We know that we're going to let this, it's a positive. In fact, it's going to look almost exactly like that. It's 2x minus 6. It's going to look like that. Let's really take it up there. We know this point here is 0 minus 6, and you can work out that point there. Well, with a gradient of 2, if we've gone up by 6, so we must have gone across by 3. But we did that whole previous video on sketching lines and whatever, so I'll leave you to do that. Okay, so now what we ask ourselves is the inverse. Now, the inverse, I said two key takeaways. The first key takeaway was what's x is y, what's y is x. And the second one is that we're reflecting about the line y equals x. So let's draw our line y equals x on this Cartesian plane. So here it is. Just drawing it as a dotted line. It's not an asymptote. I'm just drawing this line y equals x. So we're going to take this straight line and we're going to reflect it about the yellow dotted line. And we're going to get our inverse function. Now, our inverse function we're going to designate with f minus 1x. Not to the power of minus 1, just the inverse. And we'll get to the algebraic side now. But let's just stick with that picture. I said whatever was x is y, whatever is y is x. So this point here was our x-intercept. So what does our x-intercept become? Well, it becomes our y-intercept. So we got it here. So our x-intercept becomes our y-intercept. Okay, so what about this y-intercept? What does our y-intercept become? Well, the y-intercept becomes the x-intercept. So that becomes this point. I don't know why I drew that all the way over there. But this becomes the point minus 6, 0. What is x is y? What is y was x? Okay. Now we've got enough to draw our line. And take note of this when I draw this very straight line. That it's going through those 2 points, and it also goes through this point here, through the line y equals x. Now let's think, why must it go through that point? Well, this line went through that point, so if we're going to reflect about the point and it's on that line, it's not really going to go anywhere. Okay, again, just new concepts. We'll come back to this idea shortly in one of the other examples. But our key thing, what is x is y, what is y was x. X, y, y, x, okay? And it's a reflection. Those two look like they've been, reflected about that line. So we've just reflected it about. Now let's get to this, how do we get our inverse function? So our original function was y equals 2x minus 6. Could have been called just f of x equals 2x minus 6, or y equals 2x minus 6. And it said what was x is y, what is y is x. So algebraically, x equals 2y minus 6. Look, when we saw y, it became an x, and x became a y. Like the inverse. So now what we want to do is just rearrange our equation so that it's in standard form. So I'm going to add 6 to both sides. X plus 6 equals 2y. Okay, but we just want y, so let's divide both sides by 2. So we've got y equals Well, the 6 was easy, that's 3. Now you have two options. You could go x over 2, or I think it's easier to make sense of a half x, because then our gradient's quite clear. So y equals a half x plus 3. There it is, standard form in y equals. Cool, let's keep going, but this time you're given a picture. So jot down the picture as it is given. Doesn't have to be perfect, that perfect little curve I drew, but something like that. Pop it down, and then think how you're going to draw the inverse. Right, we got that picture down now. Pause and all of that if you need. Now for this one, I put a question mark. We're not given the algebraic part. But we know that this reflects about this line, y equals x. So if we had this line over here, there it would be y equals x. And if we drew the reflection, then this would be our original. What was x becomes y. So I'm going to draw directly across there. Is now that point there, 0 minus 10. And this one here directly across over there. And we've got 5, 0. Now, does this original function, f, does it ever cross the line y equals x? No, not from what we can see in this part. So therefore, our inverse function isn't going to cross that line either. So let's have a nice draw here and go, okay, now it's quite difficult to draw this and match it up and go, well, I think this shape looks something like that. It's not too bad. So a little hint, what you can do is take your paper and just rotate it 45 degrees, and it might be easier to draw. But hey, up to you. Let's see if that works for you. The point is, it's reflected about this line. What was x is y, what is y is x. Okay, next one. Example 3. This time we're given our beloved parabola. So we happily drew this before on our set of axes, x, y. We know how to draw our parabola, especially our nice basic one. It looks like that. And I'm going to redraw that. That's not that great. And I'm going to draw our parabola. Okay. Now let's label it f. And what I didn't do so well in the previous ones is labeling our diagrams. Label, label, label. So that's f. And we know it goes through this point here, 0, 0. So for our inverse function, what is x is y, what is y is x. So let's choose a point maybe on our original function. So I'm going to choose a point here. Where do I want it to be? Maybe over here. Well, let's choose a point here. Okay, so if we've got our x value at 1, let's just choose that point. Let's work out what the y value would be. So f of 1 equals, because y equals x squared, so x squared equals 1. So in other words, when we input 1, our output's 1. Okay, now this is interesting. So for our inverse function, what was x is y and what is y was x. So this point's going to stay exactly where it is, because it's actually on the line y equals x. Okay, so that point's going to stay the same place. What about 0, 0 on our inverse function? So it's going to stay where it was. But let's maybe take this other point I wanted up here and just say, well, this point, let's just choose a point of 1. This looks like about x equals 2. Let's see what that point would become. So f of 2 is 2 squared equals 4. So in other words, 2 4s on this function. Now let's get to plotting our inverse. So for our inverse, f minus 1, we know that we must have the point 1, 1. And we know we must also have this point, but remember x becomes y, y becomes x. So we must also have the point 4, 2. But now 4, 2 is more like it's over here. Like here, let's say. This is interesting. I'm just going to draw the graph. And let's see if we can make sense of it from what we've got so far. It goes through that point. It goes through 1, 1. It goes through 0, 0. And I'm going to say that it goes across that direction. Let's see. This point here is also at 4. Let's look at this point across here. If our input is -2, what would our output be? Well, it would also be 4. So in other words, 4, -2 must be on this other graph. Okay, so we're just reinforcing this idea. X, Y, Y, X. So we've got our original function, parabola here, and the inverse looks like a parabola but going the other way around, over here. Now, is the inverse, is it a function? No, definitely not a function at all. Because we could draw a vertical line and hit it twice. Look, here's a point. We hit the same input, gives us 2 outputs. Okay. What else do we want to look at here? We've drawn our inverse. We've got the original. Maybe let's have a quick look at domain and range. For our original function, f, what is our domain? Well, domain relates to x values, and we can input any x value at all. So x may be right. X is an element of negative infinity to infinity. Or you might have written x as any real number. Remember, what was x on the one function is y on the other. So for our inverse, our range is the same as the domain on the original function. So our range now is y is any real number, or you might have written in the form y goes from negative infinity to infinity. Let's look at our range here. So our range for our original parabola, well, it was only our 0 and positive numbers. So our range, we might have said, well, y is greater than or equal to 0, or you might have written y is an element of 0 up to infinity, which means that our domain, remember it was x is y, so domain becomes range. So our domain, x is greater than or equal to 0, or you might have written x is an element of 0 included up to infinity. So this last point here I want to stress is, for our original parabola, it started on the x-axis and went up. So for our inverse, we're going to start on the y-axis and go forwards. Y went positive, x goes positive on the inverse. X, y, y, x. Okay, let's go to our last example. We're going to come back to domain and range later again, but just this x, y, y, x. We are given another parabola. We drew this parabola, I think, before, so I'm going to draw it. Whoa. It's like I'm putting in golf. Okay, so we got x, y, x, y. And for this one, we know that this looks like this. And we've got these points here, here, here. And we've got, this is the point 0, minus 16. And these points here we've got are, what have we got? Negative 4, 0, and 4, 0. Okay, let's do our what is x is y, what is y is x. So here we're going to say 0, negative 16 is going to change to negative 16, 0. So it's going to be down here, and we probably need to extend our axis a bit. So this goes like that. No worries. And it goes there, and we say that's negative 16, 0. What was x is y, what is y, x? So these x-intercepts become y-intercepts. So that's going to go there. And this one's going to go here. So negative 4, 0. We're saying, oh, well, that's 0, negative 4. That's a terrible negative 4, right? Negative 4. This part here, 4, 0 is 0, 4. And now we can draw our parabola and say, okay, well, it needs to go through all of these. There's only one way we can draw a parabola that goes through all of these. And, whoa, this is getting wonky. The positive bit is going to go up here. And the negative bit is going to go over here. So this is our inverse function. And this is our original function. What is x is y, what is y is x. Now, let's work this out algebraically. F of x is this, which means that for our inverse, which is x is y, what's y is x. X equals y squared minus 16. Now, we need to make y the subject of the formula. So we got add 16 to both sides, x plus 16 equals y. Okay, squared. And this is what we need to work out, the squared now. So we need to square root each side. Square root of x plus 16 equals y. But what do you know about square roots? Well, we know to take square roots of positive numbers, and the square root of anything is positive. So that would relate to this top part of the graph. So we need to take the positive or negative square root. Say, for example, I gave you x squared equals 16. Well, x equals 4 would be one of your solutions. You would have taken the positive square root. Or you would have taken the negative square root, negative 4, because you would take positive or negative square root. So the same thing here, we're taking the positive or negative square root. So this is our inverse. Is our inverse a function? No, because it fails the vertical line test. So if we drew a line over there, it crosses twice. Okay, so how could we make it into a function? So I'm going to redraw this parabola. So have your wits about you now. Here we are. And we've got x, y. Now for our original parabola, I'm just going to look at the positive side of it. So this positive side is over here. Here's f. So f of x equals x squared minus 16. But I'm going to say x must be greater than or equal to 0. See, it's this function, but just on the positive side. Now let's look at our inverse. Our inverse, if x was greater than or equal to 0 in this one, what's going to change? What's our inverse part going to be, our inequality? Well, what is x is y. So y is greater than or equal to 0. So this means that for the original function, we only look at the positive x values. So for our inverse, we're only going to look at the positive y values. So let's look at this function here and go, oh, we're only going to look at the positive y values. So in this case, if we only looked at the positive y values, it would look like that. There's our inverse. We are going to swap x and y as we did before, and we'll get y equals the square root of x plus 16. Did I say x? Was this meant to be in... No, that's right. X plus 16. Okay, but we're only looking at the positive, so therefore we're only looking at the positive square root. We've got a point of intersection here. We know that it goes through... There's this line, y equals x. Feels like it got a bit more juicy in the last few minutes, eh? So we've got this line, y equals x. And what we've done now is we've said we only want to look at the positive x, which means the positive y of the inverse. Remember, whatever is x is y, whatever is y is x. We already worked out these intercepts. Not too worried about them now when I'm redrawing. But I do want us to find as our last bit here, what is this point of intersection? So how do we find the point of intersection between two graphs? Well, we kind of make them equal to each other. So in this case, we've got, when is our function x squared minus 16, when is it equal to the square root of x plus 16? Now this looks too complicated. We're going to do this, but wait a second. An easier way would be to say, not when does it equal the inverse, but when does it equal the straight line? Because look, this point A is the intersection between our parabola, our original parabola, and the straight line y equals x. So when is our original function, when is f equal to that straight line? The straight line y equals x. Much easier equation to solve. So now we can go, okay, well, I keep changing my mind of colors here. X squared minus x minus 16 equals 0. Okay, we try and factorize. It doesn't factorize nicely. So we put it into our quadratic formula. Minus b plus or minus the square root, blah, blah, blah. And we get our two answers. I think there were 4.53 in each case. 4.53. Because we're not interested in the other solution. Remember, y equals x, so they're going to be the same. Okay, going to be a lot easier. Again, we're going to come back to this idea of this point of intersection, but it's just a whole lot easier if you make it y equals x. Okay, so there are a few exercises now to practice and reinforce these. Exercise 2, you're going to do 1, 3, 5, and exercise 3, just 1 and 3. So these are hyperbolas, these are parabolas and straight lines. Key concept, key takeaway. What's x becomes y, what's y becomes x, and it's a reflection about the line y equals x. Oopsie, that way around. So I think it's time to go and make it maths.